So, dear students, I was explaining de Broglie wave in the last video, and I told you that wavelength associated with particle like a ball is beyond the measurement. But if we think particle, atomic size particle, then there is a wavelength which can be measured. So I want to derive here the wavelength associated with an electron. तो वैसे डी ब्रोगली वेव डी ब्रोगली wave has wavelength lambda is equal to h upon p. P is the momentum. Now let an electron of mass m and charge E, magnitude of charge only, is accelerated through a potential difference of V volt from definition of potential difference of potential difference, the kinetic energy gained by electron K, I write only K for kinetic energy equal to E into V. E the magnitude of charge of electron, V the potential difference. Listen dear student, here it is V volt, positive, negative. Electron is left from here, it will gain energy. Then kinetic energy equal to eV. Now we know that K is equal to half mv square also, or you can write m square v square upon 2m. I am driving, but we know m multiplied by this is p square upon 2m. So p square is equal to 2mk. K is the kinetic energy here, but k is equal to ev. So P square equal to 2m into eV. E the charge of electron, V the potential difference, or P equal to under root 2m eV. This relation is very important here because questions are asked in every exam on this, and hence de Broglie wavelength associated with an electron lambda is equal to h upon p under root 2m eV. Once I was in invigilation duty of IIT exam in chemistry, and this derivation was asked, and in that room no student was able to prove it. Sorry. Lambda is equal to here come out to be by lambda h upon p, and T. This so lambda is equal to H upon under root 2 MeV. M is the mass, E is the charge of electron, and H Planck constant. Now, if I putting the values of H, M and E, we get lambda equal to 6.6 10 to the power minus 34 upon 2 into mass of electron. You can take 9.0 10 to the power minus 31. Though in books they write 9.1. For simplicity I am taking like this. Into charge of electron 1.6 10 to the power minus 19 into V. It will come out in meter. So students get confused of when they find such calculation. Very simple. 10 to the power minus 31 19 power has become 50. 10 to the power minus 50 under root. It is 10 to the power minus 25 power half. So you can write 6.6 into 10 to the power minus 34 upon 10 to the power minus 25 3 under root 3.2 volt meter equal to 10 to the power minus 9 2.2 3 2.2 10 to the power minus 9 upon under root 3.2 V. Convert into angstrom, 10 to the power 10 angstrom. So it comes out to be equal to lambda. I have not put the voltage value. 1.2 under root, nearly 1.8, 18 square 3.24. Please remember something, 18 square 324. So that 1.8 square 3.24. So I can take root this as 2.2. So it is 22 upon 1.8 under root V angstrom. On solving you will get 12.27 upon under root V angstrom. This was the question there in board exam, IIT exam to prove this thing. And in that room nobody was able to prove this thing. So please take my video seriously and don't take it otherwise. I am doing the job for you will, so that you should feel the subject easy. Now I was telling you with the ball of mass 100 gram and velocity 10 meter per second, the lambda was 6.6 10 to the power minus 34 meter. So that is beyond measurement. But now if here V equal to 100 volt, if V 100 volt, then lambda will be 1.27 angstrom. This is the wavelength of, you can say, X-rays or gamma rays, and this distance is equal to the distance between atoms of crystalline solids, so which we have measured using Bragg's law of X-ray diffraction. And these wavelengths associated with electron were verified by Davison and Germer, and Rutherford also practically. And in last video I told you that electron microscope is practical application of de Broglie wave. So all this derivation was theoretical, but Germer and Davison proved it practically. The same wavelength was measured by them. So practically de Broglie wave exists, and we are applying it electron microscope. Actually, why we are applying them electron microscope? What is that? Electron microscope use electron beam in place of light, and to converge and diverge electron microscope use electric field, magnetic field in place of lenses. In optical microscope, lenses are used to obtain the image. In electron microscope, we use electric magnetic field, and the resolution power of electron microscope is more than 10,000 times that of optical instrument. But now question arises here, what is de Broglie wave? What is the physical significance of de Broglie wave? And do these waves are the same as light wave? So there was one question in board exam to differentiate between write two differences in electromagnetic wave and matter waves. Question was like this, exactly the same question. Give two difference between electromagnetic wave and matter waves. And my dear colleague was not sure. And I tell you frankly, I was also not sure. Because whenever we studied, we only were limited up to H upon P. बस काम होगा, de Broglie radiation होगा. No, the now work start now here. P equal to mp, and the wavelength associated with the particle are called matter wave. So now, if we apply here Heisenberg uncertainty principle, according to principle of uncertainty, the momentum and position of particle cannot be measured correctly simultaneously at a given time. If we are trying to measure the momentum and position of particle at a given time, then we can't measure correctly, and there is an error. Delta P error and delta X error in the position, it is error in the momentum, which we call as uncertainty. Actually, error is the uncertainty in the measurement. And according to that, delta P into delta X is greater than equal to H upon 2 pi, where H is Planck constant. Some people write it as like this, H cross. H cross means H upon 2 pi. If I take the least error product as delta P into delta X equal to H upon 2 pi. If lambda by here, lambda equal to H upon P, or P equal to H upon lambda. Then if lambda is single wavelength, there is no problem. Then P is constant and hence delta P should be 0. But delta P comes from error in the measurement. If delta P is equal to 0, then delta X should be I write here प्रॉब्लम क्या है? इफ डेल्टा पी जीरो, डेल्टा जीरो जब वेवलेंथ है डेफिनिट वैल्यू, तो डेल्टा एक्स फ्रॉम दिस रिलेशन by delta equal to h upon 2 pi into delta p. If delta p is equal to delta x equal to infinity, means we can, infinite error means we cannot locate the position of electron, or means electron is not localized in a given certain region, while electron is certainly localized. I hope you maybe you might be understanding my problem. If delta is infinity, means we are not able to find the position of particle, error infinite. So, but electron is found localized in small region also, not very small region, but some region is well defined. It means there is always error, and hence, but so here I am telling delta x infinity means, it means we cannot locate the position of electron. But electrons have, but an electron, can be localized. So delta p is not zero, so delta p has a spread of p plus minus delta p, and therefore de Broglie wavelength is not single wave, that lambda is equal to h upon p plus minus delta p. यानी कि de Broglie wavelength as electron or any other particle is not a single wave. It is a packet of waves, bundle of waves having wavelength varying from central maximum like this. Not definite, and they are localized in one region. While light waves have definite wavelength. So about de Broglie wave, you can read it from the book NCERT, please. Here it is given. So many wavelengths are associated with a given particle, not single wave. Secondly, one difference that light electromagnetic wave have definite wavelength. Definition wavelength क्या है? Distance traveled by a wave in its time period. अभी बच्चे ये भी पूछते हैं व्हाट इज वेवलेंथ, लैम्बडा होता क्या है? वेवलेंथ ऑफ लैम्बडा, वेवलेंथ ऑफ एनी वेव इज द डिस्टेंस ऑफ अ वेव इन इट्स टाइम पीरियड. सो नाउ एग्जैक्टली अभी मैं पढ़ रहा था बुक से, मैंने पढ़ा भी है पहले भी. एग्जैक्ट इंटरप्रिटेशन ऑफ de Broglie wave or matter wave is yet an area of research, but many people like Bohr apply de Broglie wave to study the structure of atom and the amplitude of square, square of amplitude इनके ए स्क्वायर ऑफ मैटर वेव्स gives the probability of finding a particle. A particle has matter wave whose amplitude is a. So a square is the probability of finding a particle per unit volume. So it is a probability of finding particle per unit volume. Per unit volume. While intensity of wave proportional to square amplitude of electron radiation is determine the intensity. While here square amplitude gives the probability of finding particles. And now what have we learned in chemistry? The orbital. I asked student what is the difference between orbital and shell. Sorry sir, we can't define. Orbital is the, in chemistry, what you study in chemistry, in structure of atom, SPTF, orbitals. There they define the probability of finding particle per unit volume. So that concept has come from de Broglie wave. Please listen me very carefully. So that way you can read the book to differentiate between electromagnetic wave and matter waves. I have given simple idea, an introductory idea about wave. So de Broglie wave are localized in small region and behave like stationary wave, which we have class 11. We have read in class 11. Stationary wave, the wave which travel in a bound medium and does not travel from one place to another, but form in a bound medium. So these waves are like that. We will discuss in Bohr theory of atom also. Thank you. We'll meet with numericals regarding photoelectric effect and de Broglie wave in next video.